Let's try another one. This one is f of x equals negative 2x squared plus 3x minus 1. And again, same directions. We are going to graph it, and we are going to identify the domain and the range. So the first thing we do is we identify a, b, and c. And as long as it's in standard form, the a value is with the x squared. In this case, a is negative 2. The b value is with the x to the first power. It's a 3. And the c value is the number without any variable, and it's negative 1. So step 1 is find the vertex. And the vertex formula is, if I could spell it right, using x equals negative b over 2a. So that's going to be negative 3, that's my b value, over 2 times negative 2. My a value is negative 2. That's going to be negative 3 over negative 4, and a negative over a negative is actually a positive, so the x value of the vertex is 3/4. You will notice that not every vertex is always at an integer. Sometimes they're going to be at fractions. So to find the y value of the vertex, the original function is, it says f of x, but that's the same as y, is negative 2x squared plus 3x minus 1. So I'm going to replace the x's with 3/4, so that it becomes negative 2 times 3/4 squared plus 3 times 3/4 minus 1. Follow your order of operations. We do exponents first. So this will be negative 2 times 3/4 squared. That means 3/4 times 3/4. That is 9/16 plus 3 times 3/4 minus 1. Then we can do our multiplication. So we'll have negative 2 times 9/16. That is going to be negative 9/8 plus 3 times 3/4, that is positive 9/4 minus 1. Negative 9/8 plus 9/4, that is actually going to be positive 9/8 minus 1. And when you take positive 9/8 minus 1, you get just 1/8. So that is the y value of the vertex. So we can say the vertex is located at, the x value is 3/4, and the y value was 1/8. So vertex is going to go over 3/4 of a block. I'll blow it up for you. We're going to go over 3/4 of a block to the right and up 1/8. So that is just going to be barely right there above the x-axis. So 3/4 of the way over to 1, and then up 1/8 of a unit. So all of that was step 1. Almost ran out of room there. Step 2 is the c value, is the y-intercept. And in this case, the y-intercept is going to be the c value of negative 1. So I will place a point on the y-axis at negative 1. And then step 3 is apply the 1-3-5 rule. We do need to take the 1-3-5 rule times the a value. And the a value was negative 2. Better scroll up there so you can see it. The a value is negative 2. So when you take the 1-3-5 rule times negative 2, what you're going to get is negative 2, negative 6, negative 10. So from the vertex, we're still going to go outward 1 unit. But now, since the 1-3-5 rule got modified to be negative 2, negative 6, negative 10, we're going to go downward because the numbers are negative, but we'll go down 2, down 6, and then if we have enough room, we'll go down 10. But a lot of times when there's a modification, we run out of room. So Starting at the vertex, you can still see the -2, -6, -10 in the lower left-hand corner. So starting at the vertex, from that point, which is only 3/4 of the way over, we will go out 1 unit both directions, and then down 2 units. So if I notice I'm going down this way, 1, 2. So I'm going to place a point right there. Then I'll go from here, I'll be going down 1, 2. So the next point goes right there. And if you look, it does look like it's going to run right through the y-axis. So despite all of these, the y-intercept, despite all of these fractions, it looks like we are on the right track. From those 2 points I just drew, now I'm going to go out 1 unit both directions. And now I'm going to go down 6. So that would be 1, 2, 3, 4, 5, 6. And on the other side, 1, 2, 3, 4, 5, 6. And I am going to definitely run out of room for the 10. So I think that's good enough to get a shape of what the graph's going to look like. So here's 1/2 of it. It's going to look very steep like that. And here's the other half of it, very steep, going that direction. Let me clean up these little dotted lines. Maybe you can be a little less distracted by it. Look about like that. And then this is what the graph looks like. Oops, I deleted some of it by accident. Let me fix that. There we go. So there is the graph of that. Notice if we compare it to the first one, it is skinnier. It is skinnier because the -2 affected the graph by stretching it. And that has the effect, and since it's negative, it actually opens downward. We also should do the domain. It is a parabola, so the domain is all real numbers. The range, again, is based upon the y value of the vertex. The y value of the vertex was 1/8, and the rest of the graph is below it. So the range is going to be y is less than or equal to 1/8. And that is the second example. Let's do one more. This one is g of x equals 3x squared minus 5. So we start out by identifying a, b, and c. A is the number in front of the x squared, and that is 3. B is supposed to be the number in front of the x term. And notice I don't see an x term in this case. And that is because the b value is actually 0. There is no x term because 0 times x is nothing. So don't assume that the b value is 5 because the b value is not 5. That is actually the c value, -5 actually. The b value in this case, since there is no x term, is 0. So we will do our vertex. Do you remember what the vertex formula is? The vertex formula is -b over 2a. So that will be -0 over 2 times 3. And 0 divided by anything, it's 0 divided by 6 is just 0. So that is the x value of the vertex. And then the y value of the vertex is we're going to plug that in. So the y value will be plugging in the x with a 0. So that is going to be 3 times 0 minus 5. 3 times 0 is 0 minus 5, which is -5. So that is the y value of the vertex. So our vertex will be located at 0, 5. Excuse me, 0, -5. I'll go ahead and place a point there at 0, -5. The second step is the y-intercept. The y-intercept is located at the c value, and the c value is -5, and notice that was also the place of the vertex, so that means we were probably correct. And then we're going to apply the 1-3-5 rule for the last rule. So the 1-3-5 rule, we're going to take it times the a value. In this case, the a value is 3. That is going to give us 3, 9, 15. So from the vertex, we will go out 1 unit each direction and up 3 units. So out 1 unit, up 1, 2, 3, a point there, out 1, 2, 3, and a point there. So there's my first set of points. And then from those points, we will go out 1 and up 9 units. And when you go up 9 units, let's go going out 1, that'll be 1, 2, 3, 4, 5, 6, 7, 8, 9. And then the other way, go out 1 and go up 1, 2, 3, 4, 5, 6, 7, 8, 9. And I'm definitely running out of room for that one before I get to the 15, so that is going to be sufficient. This is going to be a very long, skinny parabola. That value of 3 really stretched it out. Even stretched it out further than the previous one, which had a value of -2. You can see that the one we just graphed is a little bit taller and a little bit skinnier than the one we had with a value of -2. The domain, hopefully at this point you remember the domain. The domain is all real numbers. And then the range is again based upon the y value of the vertex and the direction. The y value of the vertex is -5, and the rest of the graph is above it. So the range is y is greater than or equal to -5.